Afternoon, Chairman Robert Lai, and Vice Chairman Mr. Chris Chan. Okay, and ladies and gentlemen, good afternoon. Okay, I am Kevin Tang. Okay, so this is my great honor to represent the Hong Kong Institution of Engineer to make a short presentation here. So this is my background. Okay, actually I'm from mechanical engineer, but fortunately or unfortunately, at the past 20 years, I joined the control, automation, and electronic field. Yeah, so okay. So today, I would like to share a little bit something about control, automation, and instrumentation, how to contribute in industrial 4.0. Just like Mr. Dr. Yip, he just made a quick presentation about the automation. Okay, so I would like to bring everybody one more step, how automation to the IoT, okay, Internet of Things. Okay, so here is a little bit brief history of the Industrial Revolution. So since 19th century, our producting moving from the farm to the workshop. Okay, so this is called so-called large-scale production in factory. But at that moment, it's not really a factory. Better say it's a workshop. Okay, then okay, in that period we call Industrial 1.0. Okay, then 1815 to World War One. Okay. We have electricity. Okay, electricity moved us again. We created steel. We built assembly line, and okay, now we really have a mass production. Okay, so this is secondary industrial revolution. Okay, industrial 2.0. Then information become the next revolution from 1915 to 1917. Okay, so we have automation, we have robot, we have simple computer. Okay, so the people so-called is the industrial 3.0. So nowadays, okay, we talk about industrial 4.0. Okay, some people say smart factory, smart manufacturing, or Internet of Things. Okay. So this picture gives you the idea. Okay. So that's why I say 1.0 is not really a factory; it's a workshop. Okay. You see the lady, they make a texture. Okay. Everything by hand. 2.0, the most signature industry maybe automotive. Mercedes-Benz, BMW, Ford, right, from United States. 3.0, we have robot, okay, so Mr. Yip saw that. Okay, 4.0, okay, is everything about internet, cloud. Okay, Germany is one of the first country they talk about industrial 4.0, and then United States, they have national strategy plan for advanced manufacturing. China, made in China, 2025 by our Prime Ministry, okay, Mr. Lee, and Japan, okay, Japan, industrial 4.1J. Okay, I don't understand why Japan is at 4.1. Maybe they want to more advanced than Germany. Then Hong Kong, okay, we have reindustrialization, okay, but everything I would like to say, just talk about smart manufacturing. So I try to search what is smart manufacturing or smart factory. Some people say digital factory. So what was that meaning? So I searched from the internet, from the wiki. Okay, smart manufacturing is a broader category of the manufacturing with the goal of the optimizing concept generation, product productization, and product transition. Okay, and take advantage of advanced information. So I would like to say this is a basic definition. Yeah. So smart, how smart? Okay, because you talk about smart manufacturing, smart factory, R&D, supply chain, production, QC, or logistic, or so on. So you can write a PhD paper for all of this topic, right? So how smart? This slide gives you a very good idea. Okay, I would like to say the smart manufacturing or smart factory through the IoT solution. Actually, I'm not the IT guy. Yeah, I say I'm a mechanical engineer. Okay, I work for a German company. Okay, at the past 20 years, I know the train. Okay, how from the 3.0 to 4.0, how through the IoT solution to optimize the manufacturing process, production to the customer satisfaction. Okay, so nowadays I think everybody knows what is a 3D printer, right? Everybody knows, right? So and customer they want more unique or individual product or so-called their own personality product. Okay, so I just before we start the seminar, I talked to Ben over there, right? Ben, he say he make the molding. I think talking about 10 or 15 years ago, if you make something new, I want a new mouse, but I want a special shrink, special outlook, different appearance from another manufacturer. So you cost a lot of money for the molding. But now we have 3D printing, right? So the concept, the first idea, the first concept is relatively easily to achieve, okay, or easily to implement, okay. So this is the 3D printer. This is the IoT. Even though some manufacturer, some so-called vendor, okay, they let the customer involve in the design stage, okay. They through the internet, they through the their own system to let the customer put their own opinion and then create their own product, okay. So that's why IoT solution to optimize the manufacturing process, production, to fit the customer specification, okay. So I would like to say, so this is the major advantage of Industrial 4.0. Okay, yesterday I have an overseas customer come to Hong Kong. So he's from Thailand. He asking me, hey Kelvin, what is control? What is the automation? So because we're from this field, so I think just think it simple, okay? Like Samsung, okay? Samsung have eyes, have a nose, have a skin. So this is the most fundamental thing, okay? The sensation, okay? So this is a sensor level, or so-called field device. And then you have your brain, okay? You make some calculation, consideration, or optimization. So this is PLC. And of course, you have some background software. Okay, so we have expert here, Mr. Lee. Okay, you know everything about PLC, SCADA, MES, right? So, so this is everything about the control. Okay, Industrial 4.0 sensor. Okay, sensor level. Because today we only have 20-30 minutes, so I cannot cover all the topic. But I would like to say, I would like to mention about more fundamental level, the smart sensor. Okay. Okay, smart sensor. Smart sensor is the fourth industrial revolution gather place with the move toward smart factory. Okay, smart sensor for constant monitoring of the machine performance and streamlined integrated factory factory management. Okay, so later on I will show you case study how traditional German manufacturing they integrate with a smart sensor to implement Industrial 4.0 in their production, in their product. Okay. IoT, without smart sensor, you do nothing. So, so the people say, okay, one of very fundamental component or core element is we will use more and more sensor, no matter what kind of sensor. Maybe you make a plastic, you need a temperature sensor, you need some flow sensor monitoring your production plant, or maybe you make a machine, you need to measure the pressure, the vibration, no matter which one. The sensor is nothing new, okay? I would like to say it's a very old product, but how the sensor combine with IoT, okay? The lower cost and make advance of capability of RFID tab. RFID is a kind of wireless, okay? Talk about 10, 50 years ago, you talk about wireless sensor will cost a lot of money, but I think under today's technology, everywhere is wireless, even your cell phone. So I think today nobody will use a hardwire cable to connect your cell phone, and then you still ask, is this stable or not stable? No. So when you run to the restaurant, the first thing we may ask, hey, where's the Wi-Fi? Where's the Wi-Fi password, right? So become a more and more popular. Smart sensor also impact the supply chain. Couple weeks ago, I visited one Switzerland manufacturer. Okay, they make texture machine. Okay, then in South China, and I asked that plant engineer, hey, how many components in your machine? He said more than 1,000. I said, wow, more than 1,000. So how to make sure you have a sufficient component? Because some component is very small. Okay, it's a metal machine, a screw, or even a very small O-ring, right? Then how do you make sure? You use someone, the lady worker, to count it every day, or any method? Yeah, because all their component, major component, okay. Even they set up the factory in South China, but they still import from Europe. Okay, so okay, he told me that they have a system. Okay, it's like a scale. Okay, and then put all the component inside that different scale. Okay, and then each component have some particular weight. Like okay, this screw. Okay, if 100 pieces, it have 3 kilo. Okay, then he used that electronic scale. If less than certain kilo, that means the consumption for that small metal parts is increased. Then, because a lot, okay, is not talking about 10, 20, it's talking about 1,000, okay, and then the system will automatically send the purchasing order to the supplier, place the order. Okay, this one I need more. Okay, and then they set some safety level. Okay, for that component, and then the supplier receive the order, everything automatic, and send the product to the factory. Okay, so they use this kind of method to support or make some enhancement of their supply chain to make sure low mistake or minimize the mistake. Yeah. Okay, application of the sensor, I just mentioned that temperature, humidity, flow, chemistry, gas, a lot. Okay, so I just mentioned that sensor is nothing new, but how the sensor combine with IoT or become more smart. Okay, everybody know what's Wi-Fi, right? And Bluetooth. But in our industrial world, normally we don't use Wi-Fi, Bluetooth for industrial application. Okay, we use another technology or so-called communication protocol. Okay, so we have an ocean, we have RFID, we have a CB. Okay, so maybe you ask, hey Kevin, what's the difference? Okay, cell phone, right? Everybody have. When you switch on your Bluetooth and then you try to connect your hand-free, but everybody know that it will consume a lot of your energy or power. Okay, even sometimes you touch your phone, you feel a little bit hot, especially when the network break. You know what happened for your cell phone? Your cell phone will increase the power and then keep stretching the network until collect the network. So if you collect something, some Bluetooth device, and then you bring the Bluetooth device far away, so your energy will very easily to finish it. So under this concept, if we need more sensor, okay, we need more sensor. That means we want more data, okay, to make our factory or make our production more smart. That means we need something low energy consumption, okay, or even we need unlimited energy, okay. So I search from the market, okay. I find that we have a different kind of wireless technology. From the right hand side, we have so-called Wi-Fi, okay. So you see the data rate from 11,000 to 54,000. So you watch the movie, you watch the YouTube, you need this. Bluetooth and CB, okay. But in our industrial world, we don't need such high volume transition rate. We just need 3-digit, 100 something. So CB and Ocean is one of the good choice. And okay, second, is it possibly cannot say don't use energy. Is it possibly batteryless, okay, or batteryless, or so-called is that small device can generate the energy by themselves. Okay, I find that an ocean is one of. I'm not selling an ocean. Okay, I'm not work for this company. Okay, I just try to share this technology. Okay, because I talk about almost 10 years ago. I first time visit an exhibition in Orlando at that moment, and then someone showed me an ocean. At that moment, I don't know what's that. Why they sell this device or chips? Yeah. Then talking about 10 years ago, yeah. Okay, and also it's energy harvesting wireless technology for using in buildings, smart home, and industrial application, as well as in further application fields such as Internet of Things. Okay. So one of their, I just capture the page from them. Okay, so you also can find everything from them. Okay. But I think the idea is quite good, so that's why I share here. How they energy harvesting, okay, they call harvesting, okay, that device, they use energy, but they generate the energy by the surrounding, okay. First, they can use the kinetic energy. So from the website, I find that the London bus, you know, the ring bell, okay, you want to stop the car, you want to drop off from next station, okay, you need to let the driver know that. That bell, the red color one, is use this technology. They use the kinetic, okay. You press the button, okay. They use the kinetic energy change to electric energy. Okay, so okay, you say secondary school, I also know what is kinetic energy, but I think what they do is they make the capacitor, that supercapacitor, make it very, very small, and how to store the energy. I think this is their engineering know-how, okay? And also they can use solar energy, okay, solar energy to generate some power for their sensor. And also thermal energy, the temperature difference between night and day, and also maybe the water or the fluid temperature different to generate some energy for their sensor. Okay, you can find everything here, okay? Yeah, okay, someone want to copy it, right? Yeah, okay. So here is one case study, okay, or sharing. I don't know how to pronounce this gentleman. I asked yesterday. I tried to call my colleague from Germany. Okay. Oh, they say, I said, come on again. They say is Schulhofer. Okay. So this gentleman is the leading manufacturer for industrial bearing. Okay. So this company, they have an office. They have a manufacturing plant around the world. Okay. So bearing is very important if you make a machine, because the bearing, if you have a precision or very precise and very good bearing, it will help your machine work under very good or smooth condition. Okay, so the bearing they sell to automotive, even aerospace. Okay, then they have make the long story short. They want to develop machine tools called machine tools 4.0. That's concept with a two prototype machine. What they want to know what happened of their machine, or even they sell their machine to the customer. They want to know the condition. Okay. So they put more than 60 additional sensor in each component. Okay. So I strongly believe it should be wireless sensor, right? How you put a 16 sensor and with wire, I think is quite not only cost the money and make your machine is very bulky and look like very stupid. So I strongly believe in wireless sensor. But how the sensor generate the energy, I don't know. Maybe by that technology, an ocean, or by another technology. So okay, they put more than 16 additional sensor to measuring the vibration, low flux, temperature, pressure, all of this point. Okay, so and this is the good example of how big data and big data analysis can significant benefit to the machine collect to the industrial IoT. Couple of weeks ago, I went to the Germany. Okay, I bring one of my customer visit our factory. Okay, then I see a new machine in our factory. Okay, and then I asked the engineer, hey, what is that? They say is to test the function, the reliability of the airbag system for Mercedes-Benz E-cars. Okay, so I say, hey, how you test it? Because you test it, no one know that. They say, oh, okay, that machine already installed 1,000 of the sensor, and then all the information are synchronized to the cloud. So the quality control, the product design engineer from Mercedes-Benz, they can online to see what happened of that testing equipment. So no cheating, okay? Don't try to cheating them, yeah, because 24 hours, no matter in office, at home, or anywhere, they can access. So this is one of very good example. I think this bearing manufacturer, they also do that, yeah, because they want their customer know what happened of the machine, how good of the machine, or maybe for some for aerospace, they want to make sure everything is no mistake, no error. Okay. So okay, conclusion. Industrial 4.0 or Industrial 3.0. Okay, I would like to say Industrial 3.0 is more radical. Okay, from 0, 1, 2, 3, 4. You need to finish it one by one, step by step. Okay, if one step make error or mistake, okay, you need to do it again. Okay, but Industrial 4.0, thanks to the technology of the sensor, PLC, automation, or even IoT, cloud. Okay, so we have a more horizontally solution. Okay, the customer can easily to get certification or even involve in the product design. Okay, so this is my sharing today. Thank you very much.